வெல்கம் ஸ்டூடெண்ட்ஸ். நம்ம ஆல்ரெடி பார்த்த ப்ரீவியஸ் வீடியோஸில் பார்த்த எலக்ட்ரிக் பொட்டன்ஷியல், பொட்டன்ஷியல் டிஃபரன்ஸ், எலக்ட்ரிக் பொட்டன்ஷியல் டியூ டு எ பாயிண்ட் சார்ஜ் அண்ட் எலக்ட்ரிக் பொட்டன்ஷியல் டியூ டு எ குரூப் ஆஃப் சார்ஜஸ். இந்த மூணுக்கும் ஒரு வீடியோ கிளாஸஸ் உங்களுக்கு போடுறேன், இதையும் பார்த்துக்கோங்க. எலக்ட்ரிக் பொட்டன்ஷியல் டியூ டு எ சிங்கிள் பாயிண்ட் சார்ஜ், அதுக்குரிய டெரிவேஷன்ஸ். Let Q naught be the test charge placed P at a distance x from the source of charge plus Q. The work done to move Q from P through dx against the electric force. So dW is equal to F vector dot dx vector. The value of F is Q naught E. Therefore, dW is equal to Q naught E vector dot dx vector. E is equal to Q divided by 4 pi epsilon naught x square, that is electric field. Therefore, the expression dW is equal to 1 by 4 pi epsilon naught Q naught divided by x square into dx. Therefore, the total work done to move Q from A to B is given by W is equal to integration between B to infinity, it's equal to minus integration between R to infinity 1 by 4 pi epsilon naught Q naught divided by x square into dx. Therefore, is equal to minus 1 by 4 pi epsilon naught Q naught divided by x squared is a constant. So outside of the integral we take. Now W is equal to minus 1 by 4 pi epsilon naught Q naught into integration between R to infinity 1 by x squared into dx. The work done from unit positive charge, it can be written W by Q naught is equal to Q naught divided by 4 pi epsilon naught into 1 by R. So the above value of Q naught will be cancel each other. Therefore, V is equal to Q divided by 4 pi epsilon naught R. This is the electric potential due to a single point charge expression. Now, the video class of 3 topics, that is electric potential and electric potential due to a point charge and electric potential due to a group of charges.
Electric potential. V. Consider an electrostatic field E bar due to some fixed positive charge Q at origin. Imagine a positive test charge Q being moved from point R to a point P against the repulsive force due to charge Q. The external force applied on test charge Q is Fe is equal to plus QE. The work done by this external force in moving charge Q from R to P is WRP is equal to integration from R to P F bar E dot dr bar is equal to minus Q integration from R to P E bar dot dr bar. Negative sign indicates displacement opposite in direction to force external. This work done gets stored in the form of electrostatic potential energy. At every point, charge Q possesses certain electrostatic potential energy. The above obtained work done increases PE by an amount equal to PE difference between points R and P. Thus, PE difference between R and P is delta U is equal to UP minus UR is equal to WRP. Thus, electrostatic potential energy difference between 2 points may be defined as the amount of work done by an external force in moving a charge Q in an electric field between 2 points without acceleration. Potential due to a point charge. Consider a point charge plus Q fixed at point O in free space. Let us find electric potential at P due to the charge plus Q. Let R be the distance of point P from O. Consider a point A at a distance x from O as shown. The electric field intensity at A is E is equal to 1 by 4 pi epsilon naught Q by x square away from O. If a unit positive test charge is moved from A to B, then work done is dW is equal to F bar dot dx bar dW is equal to F dx cos 180 degree is equal to minus F dot dx. Total amount of work done in bringing unit positive test charge from infinity to distance r from charge is obtained as follows. W is equal to integration between infinity and r dw is equal to minus integration between infinity and r eq naught dx is equal to minus 1 by 4 pi epsilon naught q naught integration between infinity and r dx by x square is equal to minus 1 by 4 pi epsilon naught q naught of minus 1 by x. W is equal to 1 by 4 pi epsilon naught into q naught by r. Electric potential at P is thus V is equal to W by Q naught is equal to 1 by 4 pi epsilon naught into Q by R. Note, if charge at O is positive, potential at P is also positive. Similarly, if charge at O is negative, potential at P is also negative. In the previous concept, you studied potential due to an electric dipole. In this concept, you study about potential due to system of charges. Consider point charges Q1, Q2, Q3, so on, Qn, lying at distances R1, R2, R3, so on, Rn, from point P as shown in figure. The electric potential V at point P due to individual charge is V1 is equal to 1 by 4 pi epsilon naught Q1 by R1. V2 is equal to 1 by 4 pi epsilon naught Q2 by R2. Vn is equal to 1 by 4 pi epsilon naught Qn by Rn. By the principle of superposition, the net potential at point P due to the total charge configuration is the algebraic sum of potentials due to individual charges. V is equal to V1 plus V2 plus V3 plus so on plus Vn. V is equal to 1 by 4 pi epsilon naught of Q1 by R1 plus Q2 by R2 plus so on plus Qn by Rn. V is equal to 1 by 4 pi epsilon naught sigma I is equal to 1 Qi by Ri. Note, in case of a uniformly charges conducting spherical shell of radius r carrying charge Q. 1. Potential at any point outside the shell, that is R greater than R is equal to R, is V is equal to 1 by 4 pi epsilon naught Q by R. Potential at any point inside or on the shell, that is R less than R is equal to R, is V is equal to 1 by 4 pi epsilon naught Q by R.